All right, triangle proportionality theorem, converse. And converse just means the flip of this little guy. So essentially what I'm going to do is we're going to take the idea that if we know that if two lines are parallel, then the two parallel lines break up the triangle into proportional segments. So I'm going to use that idea to try to prove whether or not DE actually is parallel to AC. And if I can prove that the proportions exist and that they're correct, then I can assume that the two lines happen to be parallel to each other. So we're going to use what we already know, which is the fact that I can create those proportions. So I'm going to create that proportion, assuming that DE is parallel to AC. But essentially what I have to do is I have to test to see if it's true or false. So is 11 over 7 equal to 5.5 divided by 3.5? That's what you have to figure out. If it's true, we can assume DE is parallel to AC. If it's false, we can then conclude that DE is not parallel to segment AC. And you have two options here. You can put 11 divided by 7 in your calculator and get a decimal. You can put 5.25 divided by 3.5 in your calculator and make sure and check to see if it has the same decimal. If they have the same decimal, it's true. Or another way that you could do this is we can test it through proportions. Does the product of 7 and 5.25, does it equal the product of 11 and 3.5? Just as easily as a calculation, except instead of dividing, you're multiplying. And when you multiply these two out, 7 times 2.5 gives us 36.75. And 11 times 3.5 gives us 38.5. Okay, clearly those two things are not equal. So I can put the slash right through the equal sign. That's saying it does not equal. And then as a result, I can say that segment DE is not parallel to segment AC. And notice again, I just took the parallel sign and I just threw a slash through it, and that indicates that they are not parallel to each other. And the reason why? Because the sides are not proportional. That's it. No distance formula for you. But that is how we prove whether or not we have parallel lines. We're going to use the converse of our triangle proportionality theorem. I'm going to run out of room on how to spell this. There we go. So again, testing, I just want to see, is DE parallel to AC? I have all the lengths of my segments, so I'm just going to create that ratio. 9 is to 3, as 10.5 is to 3.5. And again, I think the easiest thing to do is just do the cross product. Then you don't have to worry about dividing. So is 3 times 10.5 the same as 9 times 3.5? So we do a quick calculation here. 31.5 and 31.5. Yes, they are equal. As a result, we can now conclude that segment DE is parallel to segment AC because your sides are proportional. It's a quick test. I promise there's nothing more to it. It's as good as it gets. So one more. Again, I want to try to see, is MN parallel to PQ? I have all of my segments. I'm just going to set up my ratio, then make up my other ratio, and again, watch your order because the order is extremely important, and we're testing to see if this is true or false. Cross multiply. Does 42 times 48 equal 54 times 36? Quick click click in our calculator. This gets me 2016. Hey, good year. This gets me 1944. No, I'm not that old. Certainly those are not equal to each other. So as a result, we say MP is not parallel to PQ. And the reason is because the sides are not proportional.